Rapiscan is a global supplier of security equipment. We manufacture a wide range of security equipment from body scanners to X-ray machines to cargo scanning machines. Rapiscan is now the official supplier for the London 2012 Olympics and the Paralympics. The machine we design and in the manufacturing state at the moment is the RTT.
Conventional CT, you have a single source with an array of detectors that mechanically spin around, so you get a flat 2D image, which makes threat detection a lot more difficult. The real-time tomography machine is unique. It's a 360-degree tube around the conveyor belt. It has multiple X-ray sources. As the bag's going through, the RTT produces a full 3D model. You can spin it around, section it, gives the operator a better chance of spotting any hidden objects in the bag.
I think the main challenge is whether it's a complicated machine. It's got thousands of parts. I've got about 30 engineers globally. In order for these 30 engineers to talk together, to communicate, to collaborate, it was a very challenging task. The first thing that Rapiscan took on was CAD software. What do we need to stabilize? We looked at a wide range of CAD software and we went with Autodesk Inventor. That led on to what do we do to data management and what do we do to collaborate the engineers. Vault is kind of a central source of data. Problems and it's solved is actually having all the master data in one single location. Before we moved to Vault, we would exchange designs via FTP, via email. Huge files were being sent through our networks, and we had wrong revisions, wrong versions. Our manufacturing location is in Malaysia, so we would find out that they had a version of a model or a version of a machine, which wasn't to design prints, which wasn't to the final engineering model. As
we have multiple locations around the world, each engineer had a library of his own parts, and these libraries were not necessarily up to date. Designs were made using old library parts and we manufactured incorrect components. Now that we have Vault, we have one library with the latest model in it, so that when we design something, we know that it is the latest part and it is going to fit. The good thing about Vault is that it gives you a revision history. So if we've made changes to a part, I can instantly see the different revisions of that part, and I can see what the changes were and the comments on it and why those changes were made.
We use Vault as a sort of central hub to process everything. I mean, it's drawings and models are checked in and checked out through the central hub. You get a lot of shared work activity where a lot of people can be working on a lot of different things in different countries, but sort of not overlapping on the same area. We can pull stuff out, work on it, while that person knows in the other country that we are working on it and there is going to be updates to it. So they can take that into account with what work they're going to have scheduled for that day.
So once we have the 3D design data and it's 100%, meaning it has all the components, what we're looking to do is, by using Vault, is to streamline that data into various departments. To manufacturing, we streamline it into QA, we streamline it into service, and all these different departments need to be able to use that 3D CAD data to generate their tech manuals, service training manuals, quality documents. Basically, you can avoid errors by having the data in one location. By introducing a change control process, you can control the master data. When the master data is changed, everybody within the line gets information that this data is now changed.
Vault has been very easy to use. Any sort of product like this, you want to be intuitive, so you can just pick it up and run with it.
As soon as I started, it really was a lot easier, and the benefits that came out of it were, I mean, second to none. It's ridiculous not to even contemplate going for it. It really makes an absolute 100% improvement on current data management.